Hi everyone, welcome back to the GCSEMathsPro YouTube channel. So today we are going through the June or the November 2020 paper. It might be listed as June, it might be listed as November. It's the same thing basically, right? It's the same paper. So the one from 2020, paper 1 obviously, because you're going to have your paper 1 exam first in 2 weeks time. So we're just focusing on paper 1 for now. So make sure you're obviously not using a calculator for this. I'm doing great, thanks, guys. How are you guys doing? I'm actually not a teacher, by the way, so you don't have to call me miss. I'm literally just a tutor, but I appreciate it. Okay, so let's go through this one then. So the first 5 terms of an arithmetic sequence are 1, 4, 7, 10, and 13. Write down an expression in terms of n for the nth term of this sequence. This is a really nice one. We just basically have to work out obviously the difference. Arithmetic means the difference is the same every time, right? So they've changed it by 3. Oh, why is that massive? Let me change that first. Yeah, so the difference is 3, but it's not that we're adding 3 every time. Yeah, exactly, Akram. So you're going to do whatever the difference is, that's what you're multiplying by, right? So in this case it'd be 3n, so you put 3, 6, 9, 12, 15, 3 times tables, and then you go, well, how do I go from that back to my actual sequence? That's when you figure out what you need to add and subtract. So you can see here you have to add minus 2 every time. So yeah, Akram, you're right, 3n minus 2. It's literally that, just make sure you put the difference as the multiple of n. Okay, because that could be quite easy to think you have to add 3, but you don't. Okay, we've been through quite a few non-calculators now. As you can see, there's pretty much always some kind of fractions operations question, and it's normally mixed numbers as well, isn't it? So we just need to show that 2 and 1/3 multiplied by 3 and 3/4 is equal to 8 and 3/4. At least they do give us the answer. So when we're multiplying and also dividing fractions, you have to convert them into improper fractions. So 2 times, so the whole number times the denominator, right? 2 times 3 is 6. Add the 1, so 7 over 6 over 6 over 3. 7 over the same denominator, obviously. And then 3 times 4 is 12, plus 3 is 15 over the same denominator, which was 4 originally. Now I can actually multiply them. So I know I said in, I think yesterday's one, that knowing some of the 15 times tables and the 16 times tables, I feel like is quite helpful for the non-calculator paper, especially in this case. Obviously you can just do column multiplication if you like, or just add it up. But I know that 8 times 15 is 120, so I just did that minus 15. That's kind of how I worked it out, but you work out however you want to. It should be 105. Obviously 3 times 4 is 12. Now, you can either convert this back into a mixed number now, or you could try and simplify it now and then convert it back. It kind of just depends. Yeah, it was 16 yesterday, wasn't it? 16 like all the time. I feel like that's quite helpful to just recognize up to like 5 or 6 times 16. And same with 15s. So I think I just converted this back to an improper fraction first. Back into a mixed number first from an improper fraction. So I just said, well, 12 times, what was it? 12 times 8 is 96. Obviously, it gives you a bit of a hint because they've given you the 8, haven't they, anyway? So you kind of know that's going to be a whole number. 12 times 8 is 96. And then the difference, whatever's left, is 9 over 12. But then you see how they've got 3/4. So then I simplified it. You could, as I said, simplify it first and then convert it. It doesn't really matter which order you do it in. But I didn't really want to have to simplify it when it was 105. So I did it that way. So that's 3 marks, you can see that there. Okay, question 3. So the diagram shows 4 graphs. Each of the equations in the table is the equation for one of the graphs. So obviously you can't see the table, but I scroll down. We're basically looking for a negative cubic, a positive cubic, a quadratic, and a reciprocal. So we just have to match them up. Some of them are, I guess, easier than the other. I mean, I feel like the most obvious one is probably D. That one's obviously a quadratic, isn't it? Then the reciprocal one is this one at the top, A, where it's got 2 curves, these 2 lines here. That's 1 over x, the reciprocal. So that one's A. And then you just got to figure out, because obviously I know you probably roughly know what a cubic one looks like, but they've obviously put negative cubic as well. So you just have to figure out which is which. Obviously you could test out, if you weren't sure, you could test out a few numbers, but this is the positive cubic one, C. And then therefore the negative is B. So it should be B, C, B, C, D, A. Yeah, which is what you said, exactly, B, C, D, A. Sometimes it's more that you know 3 out of 4, and then the last one you just kind of process of elimination, isn't it? Sometimes that's the case, that's fine. But as long as you know obviously 3 of them, then you'll be all right with the fourth one. 2 marks. Okay, question 4. The diagram shows 4 triangles. 2 of these triangles are congruent. So write down the letters of these triangles. Congruent is when they're literally identical. So not similar. Similar is when they are the same thing, but maybe one's a bigger scale. Congruent is they're the same thing and they are the same size, and like the lengths are the same, the angles are the same, everything is the same. Is there a way to remember it? You mean to remember the previous question, question 3? The graphs, or do you mean this one? So congruent is normally that one where they say SAS, ASA, things like that, side angle, side. It's basically that one. So obviously all of these are rotated. The previous one, I don't know if there's a specific method. I just memorize them really. That's in. I just know that a quadratic is a U shape. Negative quadratic is obviously then upside down. I just know that a cubic is kind of this kind of squiggle. Sometimes a cubic looks like that as well, but you know, this is obviously a more simplified version. And I just know that reciprocal looks like this. I guess for the negative and positive one, either you remember that the positive one goes like that, in that direction, or you could test out, you can always sub in coordinates, and I know it would take you longer, right? But you could technically always sub in some coordinates and go, what if X was this, what would Y be? And then you could almost try and plot it out. I mean, obviously that would take you a lot of time. But if you really weren't sure. But these are graphs that are on the syllabus for you to memorize. That's just on the syllabus, right? You just have to know not only what do they look like, but if they showed you the graph, you know, what is their equation, things like that. So I don't know if there's like a method to memorize it. It's more just, you just have to, basically. You just have to kind of be familiar with it. Sorry, I don't think that really answers your question particularly, does it? Yeah, you just have to memorize it, basically. Okay. So which 2 are identical, basically? So basically you have to figure out which ones have not only obviously all the same angles, but in the same order. And like, for example, this 10 centimeters is in the same place as 55 on the left, 45 on the right, things like that. So sometimes you have to work out a third angle. So like this one obviously would be 80, and you go, okay, fine. And then over here you go, this next one I thought, well, 45 is over here and the 10 is here, so that doesn't match A. But does it match another one? You've got 55 here where this other one had 45, so C and B don't really, no, yeah, C and B don't match, because do you see how this angle would technically be the same as that one, and they're not, basically. If you were to rotate it, it's not in the same place. And then this one, you've got 45 and a 10, which does match the 45 and 10 over here. So then I just went, well, what would that one be? That one would have to be 55, obviously angles in a triangle, right? And then do you see how that matches the top one? You've got 45, then the side 10, then the 55 angle, and obviously 80 at the top. 45, side 10, 55. It's just kind of process of elimination, I guess. There's not really a method to it. It's just figuring out that they have the same angles and the same sides, but in the same places, like the same order. So it should be A and D. Yep. Exactly, yeah, Akram's got this. So, A and D, that one's 1 mark actually for that one. Okay, so now we've got some percentage profit. So Sean pays £10 for 24 chocolate bars. He sells all 24 bars for 50p each. Work out his percentage profit. This is just the same as, basically the same as percentage change. If you have a formula for that, it's the same thing, just the context is profit. So you can either, see how they've got £10 as a total for 24, but then they've told you the 50p each. Yeah, it basically works for that, except in this context, instead of change, the change is the profit. So you subtract them, that's still the change, isn't it? And then the original, in terms of this context, would be the cost, because obviously you have to buy the chocolate bars before you sell the chocolate bars in terms of a timeline, and then obviously times by 100. So it's basically that same formula, but just apply it in the context. So it's up to you whether you want to make them all. Do you see how they've got £10 for all 24 and then 50p each? You can either make them, you can either work out how much in total he sells them all for, or you can work out how much he bought them each for. I stuck with the £10 and made, I don't know if that makes sense what I'm saying. I made I said I work out how much did he sell them all for. So 24 times 50p is what I did, but you could do the opposite if you wanted. So 24 times the 50p, which is basically 50%, isn't it, if you think about it that way, in terms of percentages. That's £12. So that's his sales, that's his revenue, isn't it? This was his cost. So the profit is obviously £2. I know I'm writing it out fully, but you know that you can see that's £2 over the original, which is the cost, times 100. So that would be 2 out of 10 times 100, which that's, you know, not too complicated to work out. So that would be 20%. Obviously 2/10, 1/5, however you want to work that out. I mean, I feel like you'd recognise that that would be 20%. Okay, so it's basically the same as percentage change, just apply it to this, okay? Just apply it to the context. 3 marks, quite a nice one. Obviously, they've chosen nice numbers because not only are we on only question 5, but also it's not a calculator. So it's not too complicated. Okay. Question 6, this one you can't see, I've got it down there, but it's 5 marks. 5 marks. This is a big question. So we've obviously got ADC as a triangle, AED and ABC are straight lines, which you can see. I don't know why they say that, because obviously it's a triangle, right? So surely they're straight lines. Anyway, they've told you that. EB is parallel to DC, which you can see with these little arrows. That means they're parallel. And they've obviously labelled 2 angles for us. Work out the size of angle EAB. So first of all, we obviously need to identify that. E to A to B, so that's the top angle here. Now, it does also say you must give a reason for each stage of your working out. Hang on, let me just have a look at what you said. You got 85%, sorry, 95%. 1,000 minus 50. Where's the one? Oh, the 1,000 as in £10. Yeah, because, okay, hang on. Hold on, guys, let me just go back really quick. So the £10 you've converted into, like, pence, which is 1,000, that's fine. The 24 chocolate bars are sold for 50p each. It's not like he sold 50p like for all of them, if that makes sense. So do you see why? That's why I did this, because I was like, well, it's 24 lots of 50p, which is in total. I did it in pounds. You can obviously do it in pence. That's fine. £12 or 1,200 pence p. So that's the bit where this would go. That's probably where I went wrong. Yeah, so in your case, because you left it in terms of like pennies, you do 50 times 24. I just converted it into pounds because I don't know, I just felt like doing that. So I did 0.5 because that's technically 50p in terms of pounds. But yours, you could do 50 as just 50. That's also fine. And then take it away from the 1,000. Yeah. The next live, well, this is a paper. If you want another paper, the next live will be Monday. If you want just a drop-in Q&A session for, this is for like GCSEs specifically, right? This is not maths generally. The next live would be Sunday at 4:30, but that's kind of like a drop-in session. You can ask me specific questions in that one. This one, obviously, we're going through an actual paper. So the next paper will be Monday at the same time, 7 o'clock. The next kind of Q&A session will be Sunday at 4:30, if that answers your question. Yeah, so yeah, exactly. You should do that and then minus your 1,000 for the £10. Okay, so you should get 20%. I think also because if you think about it, 95%, in terms of the context of profit, 95% is like extremely high. So you can almost think, does my answer actually make sense in terms of like a number as well? That's kind of helpful when you go through, analyze your answer and go, does that make kind of sense in terms of a number? It's probably unlikely to be 95%. I mean, that'd be great if it was, but it's probably unlikely. Okay, so back to this one, it's 5 marks. The thing I was about to say, though, is you see how it's not really that complicated, because obviously, again, we're still only on question 6. it says you must give a reason for each stage of your working. So the fact that it's 5 marks, like don't get kind of scared by that. I think it's only 3 marks for the work. Well, 2 marks for the working, 1 mark for the answer, and then 2 marks for your reasons. So the actual, because you might look at this and go, oh, it must be really complicated because there's loads of marks, but it's actually not. It's just that they have marks for your answers and your reasons. So this, I mean, the same with circle theorems and any kind of angles really. It's you can probably do it different ways. The way that I thought to do it was the 140. I was thinking this is a triangle up here, so ultimately if I can work out angle E and angle B, then I can just do a triangle. So I worked out this one first. I normally label it A, B, E. Kind of do that to make it look like an angle, but don't really have to if you don't want to. This is on a straight line, isn't it? So I did 180 minus 148. So that's 32. And then it says give a reason for each stage you're working. Probably means because a GCSE is normally UK, but I don't know if you're doing GCSE. Are you doing like international GCSE maybe? Which is obviously very similar. It's pretty much the same thing. Maybe that's what he was wondering about. So angles, and I would just write angles on a straight line. It doesn't have to be a full sentence. Equal 180 or add up to 180. That's one reason, isn't it? So that one there is 32. And then here, there's 63. So they only give you information you need. Is that they literally only give you information you need. So you can kind of almost tick it off. I've used the 148. I obviously now need to use the 63. So do you see how we haven't also used the information about parallel lines either? We've used the information about the straight lines, but not the parallel lines. So that's when we're going to use our parallel lines. You could use co-interior, but then you'd have to then do a straight line again, which you can do. That's fine. But there's a more direct way. You could just use, you know, the one that's corresponding angles? It's like a F shape. Well, in this case, it's like an upside down back to front F. You can skip straight to this, and that's also 63 because of corresponding angles. Yeah, so you're right. You can use co-interior. You could work out this one, and then you could do a straight line. That would also get you all the marks. It's just that you're giving yourself an extra step, which is fine. It's not wrong. They'll give you the marks. That's completely fine. It's just like there is a more direct way if you wanted it. That's all. That's why I was saying at the start that sometimes people do this in different ways. That's absolutely fine, as long as you get the same answer at the end. So yeah, more direct would be corresponding angle. So I would just literally say it's 63 because corresponding, you have to know the word, angles are the same or are equal, whatever you want to call it. Okay, and now I'm on my last step. So as I said, because I was looking for it to be, you know, it is a triangle at the top, isn't it? We obviously all know that angles in a triangle add up to 180, so that's my last step. So what do they call it? EAB. So 180 minus both of the others. So 32 plus 63. So that's 95. Take that away is 85. And then you just write because angles in a triangle add up to 180. You know, it's kind of self-explanatory. Like, I feel like it seems too obvious, but that is just, they want you to write down exactly what you've done. Again, doesn't need to be doesn't need to be a full sentence. And then that's the 5 marks. So you get 2 marks for your working, 1 mark for the answer. The answer is obviously the 85. And then 2 marks for your reasons. So the reasons are important, right? Make sure you write the reasons if they ask for them, because you don't want to lose 2 marks just for not writing it down. Because obviously you know what the reasons are if you've actually worked it out, don't you? So yeah, 5 marks just not really for the working, but because you've also got reasons. Yeah, if you're doing GCSE but internationally, a lot of it's the same. It's kind of like an overlap, isn't it? So your syllabus might have some extra things, or it might have a couple of things that, you might not have a couple of things that come up here, but most of it will be the same. So these papers might also be helpful. It also just depends what exam board you're doing. I don't know if you're doing Edexcel, or you might be doing a different exam board. Because I know Edexcel does do an IGCSE, in which case it's very similar. So it would be helpful. If you're doing a different exam board, I'd probably recommend sticking to your own exam board. because then you can get used to the questions as well as the maths. I feel like that's really important. Getting used to your own exam board is super helpful. Okay, you probably haven't seen this quite a lot. This doesn't come up very often, but this is a stem and leaf graph here. Well, diagram they've said. So the table shows information about the heights in centimeters of a group of year 9 girls. So that's the table, right? And then separately to that, this stem and leaf diagram shows information about the heights in centimeters of a group of 15 year 9 boys. They've obviously given you the key and all of that. Compare the distribution of heights of the girls with the distribution of the heights of the boys. Now it's 3 marks. Normally this is a 2-mark question. Right? Normally this is a 2-mark question, and I feel like normally it comes up with box plots. I don't know if you've seen that. Normally it comes up in box plots. Compare the 2 box plots. Or, well, they say compare the distribution, but it's obviously of 2 box plots. It's exactly the same answer. The only reason why this one is 3 marks is because they want you to write down some of the data. That's the only reason. So, when they say compare distribution, and it's in this context, it's in box plots, whatever, you want to mention 2 things. The first one is the median. And when it says compare, they literally mean compare. Okay? Make a comparison. So just say this one is bigger than the other one, or this one is smaller than the other one. Like, it's super straightforward. You don't have to explain it. You don't have to analyze it. Literally just make a kind of straightforward comparison, like an observation. Okay, so they've obviously, for the girls, they've given you the median here. But for the boys, you see how we'd have to work out the median, right? So that's why you've got an extra mark, because we have to work it out. So the median of a stem and leaf diagram, there was 15 boys. So I'm going to you can either cross off on both ends if you like, or effectively half of that is number 8. So 1, 2, 3, 4, 5, 6, 7, and then 8. But that's obviously not 8, that's like 168, isn't it? So then I make my comparison. So I would say something like, you have to relate it to the context, right? So I would say the median heights, related to the context, of the boy, again, it doesn't have to be a full sentence, of boys is, well, I'd probably put it in brackets. So it's actually 168, isn't it? Is higher, or is bigger, or is greater, or, you know, whatever letter, whatever word you want to use, whatever synonym you want to use, is bigger than the median height, or heights, of girls. Sorry, I hope you can read what I'm saying. And then in brackets, you can write the girls one, which was 165. Literally, you're just making a comparison, okay? And then number 2, the second thing you need to mention is, now normally it's like a spread. So you're either going to mention the interquartile range or just the range in general. Now, normally with box plots, I like to do the interquartile range, but because this one, if you have a look, do you see how we don't have enough information from the table for the girls? We don't have that. We don't have the interquartile range. So but they've given us the least and the greatest, which is the range. So in this case, I'm going to use the range, okay? So either the whole range or the interquartile range, whichever one relates. So in this case, you see how I'd work out the range? You obviously subtract them, right? Which is, for the girls, is 20. And then for the boys, kind of rub out this one, the whole range, so the biggest they've got, the greatest height is 182, and then the smallest is 158, so you subtract those and you should get 24. And then again, you literally make a comparison, okay? So I would say the range of heights of boys, and I'll put in brackets the numbers, 24, obviously make sure you don't get the numbers wrong, otherwise you'll lose the marks, is again bigger than the range of heights of girls, which was 20. Again, I'm saying you're literally making the comparison. It seems almost too straightforward. You're not analysing anything, you're not explaining why, you're not analysing it, you're just literally you're stating what's there, you're stating the obvious, stating the facts. So this one is really nice because if you see this question, it's the same every time. So it's just one to kind of memorize, because I feel like the worded questions can be the hardest, can't they? Girls medium, so on average the boys are taller. Boys have small. Boys have tallest height. Girls have. Okay, I'd say the first bit, the boy median 168 centimeters, girls median 165. So on average, the boys are taller. I think that would be fine. Get the mark scheme up, because they obviously give you examples. This is why I say it's quite handy to look at the mark scheme as well, so that you know what your exam board would accept and what they wouldn't. So hang on, what have they said in the mark scheme? So the first mark they've said is for identification of the range of the girls, which is 20, or the range of the boys, which is 24, or the median 168 for the boys. So the fact that you wrote 168 centimeters for the boys is 1 mark. So you've got that. Then it says 2 marks for the comparison. So you get 1 mark for the figures and then 2 marks for the comparison. So for correct comparison of medians and a correct comparison of ranges supported by both correct figures. So they've said, let me drag it over here so you can see what I'm saying. Here. Zoom out a bit, hopefully you can see that. Do you see how the first mark is for just one of the numbers? Literally just one of the numbers. As long as you get one of the numbers right, then that's the first mark. Obviously not the 165 because that's on the table, but any of the others that you calculated. Then they've said, so for example, they've said the median height for girls, and in brackets the number, is less than a median height of boys. I obviously wrote it the other way around, so I said is bigger. That's fine. And the range for the girls, 20, is less than the range for the boys. Again, I did it the other way around. It says at least one comparison must be in context referring to the height or quoting centimeters, which is what I was saying. Make it relate to the question, right? So don't just say the median is this, the range is this. Say the median of heights of whatever it is. You'll only get 1 mark for that second part if you've said for a correct comparison of medians or for the ranges. Now, what I would say for your answer is you have compared the medians, but the bit that you said after that, you said boys have tallest height of 182 to. I don't think the second bit. I don't know about the second bit because you haven't really mentioned a range. What you've done is compared to the highest and the smallest, like the greatest and the smallest. You haven't made reference to a range. Does that make sense? So I'm not sure about this. Definitely 2 out of 3. I don't know about that third bit. What I would say is make sure that you've mentioned, do you see how they've said a comparison of ranges? Not a comparison of the greatest and the smallest, that they want you to calculate the range, the difference between. So I think maybe just double check that bit. But it's always the same. When they say compare distribution, compare the medians, compare some form of range, whether it's the whole range like this one was, or whether it's an interquartile range. Sometimes that can be the case. It doesn't really matter. Which grade or class are you teaching this? Because this is also... So this is, well, I'll give you age because I feel like grades don't necessarily correlate, internationally. This is for age, as in this paper, these guys will be doing it. Most of them are probably 16. Obviously, some of them are still 15 years old. Obviously, we're at the start of the paper, so like the level of this topic is probably taught when they're younger, but it's still in the exam at the end when they're 15, 16. I don't know if that makes sense. So the level of this, I don't know, maybe age 13, but you actually still do it in your exam when you're 15, 16. Obviously, the paper will get harder as we go through. So, question 8. The diagram shows a prism placed on a horizontal floor. They've given you the formula here. I don't know if you knew this. You don't need to know the formula for pressure. They will give it to you. The one they don't give you is density. Density, mass, volume. That one you need to memorize, just FYI. So, the prism has a height of 3 meters and the volume of the prism is 18 meters cubed. So they haven't given us the area. That's the bit they're hinting towards there. The pressure on the floor due to the prism is 75 newtons per meter squared. Work out the force. I normally like to use a little, you can obviously rearrange this, but I like to use my formula triangle. Force is at the top, pressure, area. So in order to find the force, I need to multiply pressure and area. Now, I've obviously got the pressure, I don't have the area. And that's why they've given me this, because volume is related to area, isn't it? Because it's a prism. So, I need to first work out the area. Technically, in order to find the volume, you would do area of this face, which is touching the floor, multiplied by the height, which in this case is 3, you get 18. So you see it, you just have to reverse that. So the area is 18 divided by 3. So now I've got the area, I've also got the pressure. All I now need to do is work out the force. So force is pressure, 75, times the area, which is 6. I just basically doubled it to get 150 and then times it by 3, which is 450. Again, that's the 15 times tables. That's how I did it. You might want to use column multiplication. However you want to multiply, it's fine. Yeah, I don't know how the levels, like in my head, we just go on ages, so I don't know how that relates to what your levels are, but if the age gives you some kind of indication, then hopefully that works. So yeah, 450 newtons. That's quite a nice one, that one. Okay, a little bit of, I mean, it's kind of standard form, but kind of also not. So write these numbers in order of size, start with the smallest. So I just kind of had a little look through them. You can obviously convert them all to proper, where did the 6, oh, sorry, hang on, let me go back. The 6 here. So do you see how the formula says you need area, but in the question they didn't mention area, so we had to find the area. So that's why they give us this information here. They said the height was 3, and then the whole volume is 18. Now it is on the formula sheet. The volume of I mean, technically also, but that's not necessarily, the number of sides isn't related actually. I mean, it's just a coincidence that it happens to be 6. Yeah, it's not the same thing. So what we want to work out for force, what you need, when it says area, it's referring to the 2D surface that is touching whatever, I mean, in this case, it's the floor, right? So we had to work out this area here. Now, they told us the volume of the whole thing, and they told us the height. Yeah, exactly. So volume is equal to area times, well, as in the area is the cross-section, right? So the area or the cross-section times by the height or the length. So on your formula sheet, you do actually have that volume of a prism. Volume is equal to the area of the cross-section, which they mean this bit here, multiplied in this case by the height. So all I did was I was like, well, I know the volume is 18. I don't know the area, that's what I want to find out, but I do know the height. And then do you see how that's just an equation? So I just divided by 3. So if you do 18 divided by 3, you should get the area. Oh, why is that written like that? Area, which 18 divided by 3 is 6. That's like a longer. That's where it came from, the 6. Yeah, you get the equation exactly. So that's where the area, I had to work out the area because in the pressure formula, the force, pressure, area formula, there's obviously area. So you need to know. That's quite complicated. I don't know. I'm not sure. Where does the 3 root 3 come from? Over 3 root 3 over 2. Is that? Maybe that's the area of a hexagon. Just in a more complicated way. We didn't need that in this question, but maybe, yeah, maybe that's how you'd work out the area of a hexagon generally. Yeah, I think that's maybe to do with, I mean, in GCSE maths, you don't tend to have to work out the area of a hexagon, but maybe that's the formula for it, I'm guessing. Because I think you have to split it into 6 equilateral triangles, and then you have like sine rule, or what was it? The area rule, trigonometric area, half AB times C, times sine C. But we obviously don't. Yeah, I don't know if that's correct generally, but in terms of this context, in terms of this question, we don't need anything that complicated, because again, we're just at the start of the paper right now. This is still quite low level stuff. We've not got to the point where it would be much harder at the end, if that makes sense. So yeah, just think when you're at the start of the paper, just think this should be fairly straightforward. We're not quite at the end of the paper yet. It shouldn't be too complicated. That's kind of how I look at it. So we need to put these numbers in size order. You can obviously write them all as ordinary numbers if you want, or you can kind of just look at it and get an idea in your head. Depends how you work. The way that I did it is I was like, I think I literally wrote down that this would get bigger. So I was like, that's going to be big. Then this one I was like, well, that's going to get smaller, and I think I actually did just work it out. I did 1, 2, 3, 4, so there's 0.00672. That one is, I looked at it and went, well, that's bigger than the first one. That's basically what I did. I was like, that's even bigger than that one. And then this one you can see as it is. So then I just went, right, okay, well, obviously the smallest is the one on the right because it's got 3 zeros there. Then it's the 62.7 because that one has 2 zeros times 10 to the power minus 4. Then it's the first one. In this case, yeah, you have to put them in order. It's not a multiple choice. If that makes sense, you're putting them in order. But C is the biggest one, if that's what you mean. And then this one here, 6.72. It's just about moving the decimal place, basically. And then 672 times 10 to the power 4. That should be your answer. But you can convert them all into actual, well, the other 3 into actual numbers if you find that helpful. Okay, so 2 marks there. Okay, question 10, getting towards the middle now, so it's going to obviously level up a little bit. This one, I don't think I knew about this when I was in GCSE. I don't really remember knowing about this, but anyway, it's just knowing how you can convert ratios and equations. Basically, once you know how to do it, then it's fine. Yeah, you're going to want to do that. The way that, again, there's probably different ways to do it. The way that I did it is I first made them both into their separate ratios. That's what I did. I made the ratios first, then I made the b's the same in the ratio. Now, I'm assuming you could probably use the equations first and then get there. Well, they've asked for a ratio. Yeah, exactly. So what you basically do when it's laid out like this, you just take it across. So like the A is 2 and then the B is 5. So that's one ratio, right? That's a separate ratio. So A to B, in that case, would be 2 to 5. And then you do the same for the second one. So then you get B to C is 3 to 4. Exactly. And then I just went, well, I need to combine the B's because they obviously both have B's in them. That's where it overlaps. But they're not currently the same scale. So I need to find the lowest common multiple, which is obviously 15. So the first ratio, to get to 15, I have to times by 3. So do that on the other side. And the second ratio, to get to 15, I have to times by 5. So do that on the other side. Yeah, I think there's like different ways to do this one, to be honest. It's whatever kind of naturally makes sense to you. My method might be different to what you might think would make sense. Do you know what I mean? You don't necessarily have to do it my way. As long as you get the same answer, it really doesn't matter what method you use. So you should get, at the end, as long as you get 6 to 15 to 20. Yeah, whatever way makes sense to you. As I said, it doesn't have to be the way that I've done it. It could be a different way. As long as you've got the same answer, then it really doesn't matter which method you use. So that's just the way that I kind of naturally looked at it. I mean, you might look at it from a different angle, which is also fine. Oh, you got 2 to 5 to... Oh, I see what you're saying. 20 over 3. As long as it's a multiple of this... yeah, that's technically correct. Like that does make sense. Hang on, let me get where did I put the mark scheme? I like to have ratios as whole numbers. That's why I did it like that. But yours is a fraction, which, what's this question 10? They have said or equivalent. And because in the question they haven't specified that it has to be whole numbers, so I would imagine they would allow that. I hadn't thought to put it that way, but you're not wrong. That is the correct answer. Yeah, because you did 6 divided by 3, which is 2, 15 divided by 3, which is 5, but then 20 divided by 3 is 20 over 3, isn't it? So yeah, you are right. I think that's fine. I just, when I do ratios personally, I tend to just use whole numbers, but that's just my own preference, really. I just don't really like fractions. I just try and avoid decimals and fractions. That's the only reason. But it is an equivalent version. Now, if they had said in the question, give your answers as whole numbers, then you wouldn't get the mark, right? Because it had to be a whole number. In this case, they haven't specified, so it's fine. But just double check your question, because sometimes they do specify, and they do want it to be a whole number. So just double check. But in this case, it's fine. Please, can you, how do you get 6 and 15? Yes, sorry, I didn't really draw it, did I? So the lowest common multiple So if you think about the 5 and the 3 times tables, yeah, is that okay? Is 15, isn't it? 3 times 5 is 15. So then on this side, I had to times by 3, because obviously 5 to 15 is 3. And then on this side, I had to times by 5 to make the 15, and then obviously you do the same on both sides of the ratio. Same here, times by, hopefully that makes sense. Yeah. So that's where the 15 came from, and a 6 and 20. Okay, so it's quite small. I'm going to make this a bit bigger. So we've seen this a lot before. You're going to get some kind of indices, aren't you, at some point in this paper. The first one I feel like might be a little bit tricky to kind of know what to do. So find the value of the 4th root of 81 times 10 to the power of 8. Now, what I did with this one is, if you think about how surds work, I know that you normally do surds with just square root and not a different type of root, but you can use the same logic. You can split them. So you can do root that, which they won't make you do the 4th root of something that doesn't, root in that way. So this is one that I would recommend you memorize. The 4th root of 81 is 3. Because 3 times 3 is 9, times 3 is 27, times 3 is 81. I would recommend you just memorize that 3 to the power of 4 is 81. Obviously it's 9 squared, but it's also 81 exactly. I would probably just recommend you memorize that. And then you've also got, obviously then, the 4th root of 10 to the power of 8, which doesn't, but what I would do in this case is I would use fractional powers. How can I write that as a fraction? So 10 to the power of 8 in brackets, that's to the power of a quarter. And now do you see how that's just like index laws, the third one where you multiply the powers? So that's the same as 10, and then you do 8 times a quarter. So a quarter of 8 is 2. Do you see how that's just 3 times 10 squared? Now that's a lot more easy to kind of figure out, isn't it? And they said the value, so I'm actually going to work it out. So that's 3 times 100, which is obviously 300. That's what I would do. I wouldn't start working out 81 times 10 to the power of 8. I think that would be just too... Again, think of the parameters of a non-calculated question. I feel like that would be too hard. So I would try and break it down first and then multiply at the end. But yeah, I think that was probably one that's a little bit more complicated to know that you can do that with that one. Okay, find the value of 64 to the power of negative a half. This one should be fairly straightforward. I normally do the negative first, just because I feel like I'll forget otherwise. You don't have to do it first, but I normally do it first. So that means reciprocal 1 over 64. Then to the power of a half, which means square root. So obviously square root of 1 is 1. Square root of 64 is 8. 1/8. Oh, you just have to memorize, with fractional powers, as we've just done here. If you have the power of a half, the denominator of that fraction is the type of root. That's just something you have to know. That's just what it is. That's just how it works. So that's why I square rooted this one, because do you see how the denominator was 2? So that's square root. And then here, because it was like a 4th root, therefore the denominator was 4. And for example, if it's to the power of a third, then that would mean cube root, right? That's just how it works, basically. Yeah. Exactly, yeah. You apply the denominator as a root, and then the numerator is just a normal power. Exactly. So yeah, it works both ways. Like if you've been given the fractional power, you root it. If you've been given the root, you can put it back as a fractional power if you feel like that makes sense in the question. So you can reverse it. And obviously the numbers correlate. Okay, part C. Write 3 to the power of n over 9 to the power of n minus 1 as a power of 3. So everything is a power of 3. So we're going to break down the 9 first, because obviously the first 3 is fine, isn't it? Leave that there. Instead of writing 9, do you see how I could write 3 squared? And then still to the power of n minus 1? And then that's again the same index law that we used in part A. I need to multiply these powers. So that's still 3 to the power of n at the top. And then this is kind of like expanding brackets, so it's 3 to the power of 2n, but also minus 2, isn't it? You're timesing everything by 2. And then, now because that's a divide symbol, and they're both in terms of 3 as a base number, the index law we're using is subtract, isn't it? Just be careful when you subtract it though, because you're taking away the whole of the 2n minus 2. So, do you see how that would give me n minus 2n is minus n, But then do you see how the 2 would become positive? Yeah, just be careful with that negative there. We're also subtracting the 2, but the 2 was negative already. So do you see how that's a double negative? So it'd be plus 2. That's why I put it in brackets. Just be really careful. I think they've done that deliberately. It's a bit of a trick question. So you can write it like this. I kind of naturally wrote it as 2 minus n because I don't really like having a negative at the front, but it doesn't really matter. It's the same thing, isn't it? This or this is your answer. Yeah, just be really careful. If you're ever subtracting something that's got more than one term, I would... So yeah, if you're ever subtracting something that's got more than one term, I put it in brackets to remind myself that I'm subtracting the 2n, but I'm also subtracting minus 2. Exactly, but then you ended up not subtracting the 2, didn't you? Because I'm subtracting all of this, but if I subtract a negative, it becomes positive, so that 2 becomes positive. That's why I put brackets, to kind of remind myself. But yeah, because otherwise if you just wrote it like this, the only thing you're subtracting is just the 2n. You're not subtracting the other 2, and you have to subtract both. I don't know if that makes sense. Let's see. Yeah, you'd get 1 mark for that, exactly. So yeah, whenever, and it's not just in the context of indices, whenever I'm subtracting, 2 terms, 3 terms, I always put those in a bracket so that I remember. Yeah, I can go back through it again. So they said they want everything as a power of 3, so they want 3 to be the base number, right? So that, you see how my answer has a 3 and then the power of something. So the 3 at the top is already 3. So I don't need to change that currently, right? So I left that where it was. But the 9, that was my problem, wasn't it? The 9, I wanted it in terms of 3. I don't want a 9. So you see how 9 can be rewritten as 3 squared instead? As in 9 is the same thing, isn't it? 9 is equal to 3 squared. That's the same thing. So I just replaced it, basically. And then, because I ended up with these brackets, I had to multiply the powers. That's just one of the index laws. You might have to just go check through the index laws. Whenever you've got these brackets and just one base number, you multiply the powers. So it's kind of like doing this, expanding the brackets. Do you see how I got 2n and then minus 2? That's where this second bit came from. Let me highlight it for you. That's that bit. This bit here is this bit, right? I just didn't write it down, basically. And then another index law, which again, you just have to know them, you just have to learn them and memorize them, is whenever there's a divide, so I could rewrite it if you want as, that's the same thing as writing 3 to the power of n divided by 3 to the power of n, 2n minus 2. That's the same thing as that fraction, isn't it? And then in terms of when you have divide like this, and you see how they're both the base number 3, index laws tells you that therefore you have to subtract the powers. So that's why over here, let me rub out this bit. That's why over here I subtracted the powers, right? So I did n subtract the whole of 2n minus 2, which means n minus 2n, which is negative n. And then because I have subtract minus 2, it becomes a positive 2 because it's a double negative. So then I ended up with minus n plus 2, or if you want to write it the other way around, you can write it the other way around. These two are exactly the same. I just flipped it because I didn't like how it looked. So as long as you've written one of these two answers, then that's the answer. I don't know if that answers your question. It might be that if you haven't seen the index laws. No, so n minus 2n is negative n. So it'd be negative n because it's like doing 1 minus 2. If you do 1 minus 2, you get minus 1, don't you? If you think about the number line, you're going negative. So it's negative n. Yeah. Like, because this n is technically a 1n, isn't it? 1 minus 2 is minus 1, so that's why it was minus n. Yeah, The other one became positive because there was a double negative. That's why. Yeah, okay, perfect. All right, so again, we've got cumulative frequency. I don't know if you noticed this by now, but cumulative frequency seems to come up quite a lot on the non-calculator for some reason. So the first thing, we've got the table gives information about the weekly wages of 80 people. Complete the cumulative frequency table. This is really easy, as you can see. Yeah, I think I went through this one and this one wasn't bad either, actually. I mean, once you get to a certain point where they're actually not that bad anyway, because you're ready to do them, you know. So it's only 1 mark, so all you need to do is add up the numbers. So the first row is always the same, right? It's always, well, in this case it's 5, but then add 10, which is 15, add 20, which is 35. Like, literally every time you're just adding another row. That's why it's only 1 mark. What's that? I think that was 70, and then obviously your final row should add up to the same number. If they gave you a total in the question, then it should make the same total. You can always double check that. So that's 1 mark. Now they then said part B, on the grid opposite, draw a cumulative frequency graph. If they make you do the table, they're pretty much going to make you do the graph, right? So that's pretty guaranteed. So I'm just going to copy this table because obviously on mine it's on a separate page. When you do your paper, you'll be able to see both at the same time. Is it going to let me paste it? Paste, please paste. Try again. I don't know why it stops working sometimes. Apparently not. Okay, that's fine. So 250, 300, it's 5. I'm just going to copy the numbers. 5, 15, 35, 55. Obviously on yours you'll be able to see both pages at the same time if you have your paper. So there, and then it was 250, 300. I mean, you can kind of see, normally it's laid out on the x-axis pretty obviously there. 400, 450, and 500. Okay, just a note. Again, we keep saying this, but you're meant to plot the right-hand side of your range on the x. Yeah, yesterday's was pretty nice as well, wasn't it? I don't know. Yeah, so this is the one with the end of the class width. This is the one where you put it at the end, so the right-hand side. The one where you work out the midpoint and then you plot it is called frequency polygons. Right, frequency polygons. It doesn't come up that much. It's not as common as cumulative frequency. But if it says draw a frequency polygon, you'll have a frequency table like the first one. You find the midpoint, and then you obviously plot the frequency as it is, and it looks kind of like a jaggedy. Well, I guess like it looks a bit like this, like a polygon type of thing. And you do straight lines. Yeah, that's the only one that goes in the middle. The only other time where it's in the middle, which I don't know if you're thinking of this, but it's not to do with the graph. It is to do with the frequency table. But you know the topic where it says mean from a frequency table? It gives you a table, let's say like this, and it says work out an estimate for the mean. That's the one where you also have to work out the midpoint, and then you do frequency multiplied by the midpoint. But it's not a graph, right? It's just an average. It's just working out the mean. So I don't know if you're thinking of that. Those are the only 2 times, I guess, where you work out a midpoint in terms of a frequency table. But yeah, in terms of a histogram, you've got, yeah, histograms use a frequency table, but you don't use the midpoint for a histogram. You do for a histogram, you have to use the table to work out the frequency density, isn't it? Do you remember that? So you have this formula here, formula triangle, frequency density, class width, and then to find out the frequency density, you divide these. So that's not the midpoint. I don't know why I keep calling it midterm. That's not the midpoint. But yeah, they are all based around a frequency table. Like the original table is kind of the same thing, isn't it? I actually don't do classes on Zoom, no. I've not really thought to do it. It's more because I need to kind of be able to draw, and I feel like, I don't know if you can do that. Well, maybe you can do that on Zoom, I don't know. Yeah, I've not really looked into it, to be honest. I've only just started doing these lives like 3 weeks ago anyway, so yeah, I'm just figuring it out really. So no, I don't currently do that. Yeah, it's because you need like an actual, like I want like a whiteboard to be able to draw on. That's kind of the issue, isn't it? with maths particularly. Anyway, so let me draw this. So as I said, it's on the right hand column of your table. So 250 at 5, just be careful of the scale. Sometimes the scales are a bit difficult. This one I think is quite nice though. 15, 35. Obviously your graph for cumulative frequency should always be increasing. If it's not increasing, something has gone wrong. And then up to the total, which in this case is 80. You can see it's always going up. Now this is going to be a curve. Okay, it's not straight lines, it's a curve. Obviously do it in pencil on your actual exam, just in case you need to rub it out, but I'm going to try my best. That's not very accurate at all. Well, it's quite hard to do it digitally. Obviously you should be able to do a better job on your piece of paper than I can. Something like that. Obviously yours will be a bit more stable than mine. Well, that was horrible. What is going on here? Need to like zoom out maybe. Yeah, I don't know why it's so hard digitally to do this, but anyway. Oh my goodness. Okay, that's a bit better. Okay, roughly. I'm trying to do it well because the thing is, in the next part we need to use the graph, and obviously I want my answer to be roughly accurate. But yeah, it is much easier on a piece of paper, I promise, than what I'm making it look like. Okay, something like that. It should be a nice, that should be a nice curve. Okay, right, what zoom did I have? There we go. Right, I'm just going to go back because part C was on the other page, so don't forget that there is a part C, right? You don't want to lose those marks. So down here. Okay, part C. So Juan says 60% of this group of people have a weekly wage of £360 or less. Is he correct? So I'm going to go back to my graph, and where it says, there's different ways to do this, but where it says 360, I'm going to do that on my graph. Again, be careful of the scale, right? Because it's a little bit of a tricky scale. So £50 is 10 squares. So every 2 squares is £10, isn't it? So just be careful of the scale. Draw a line at 360. That's how I kind of like to do it. Get my line a bit smaller, 360. So 2 squares along from 350. Draw a line up. There, and then across. Oh, okay, luckily this is quite a nice number then. That's not straight, but you can see it's basically should hit roughly 40. Line of best fit is scatter graphs. Scatter graphs, just scatter graphs. So they'll give you a load of different points. You try and draw a line through it and try and get as many, kind of, I guess try and get your line to go through as many points as you can, but also think about having as many of the points above your line as below. That is 360. Yeah, so I'm saying there's different ways to do it. So you could do the kind of, the way that I thought was just doing it this way and then seeing if that makes 60%. What you did was work out 60% and then go backwards, which is also fine. Now, what was it? 60% of 80 should be 48. So you might have gone on your graph. Let me get a different color. This is another option, right? You can do this. And gone at 48 and gone across. Now, what did I get? That's kind of roughly on this square here. I think that should be 380. That's not 370. I think you should get 380 if you do it that way. 380, right? And then you would conclude that way. So you can do it that way. That's also fine. Yeah, you can do it that way, but as long as you get 380, not 370, then that's fine. How is that 360? Just because of the scale, that's just where this bit here is where 360 is. I just figured out the scale of the graph, if that makes sense. Yeah, it said 360 in the question. I didn't just like randomly. Yeah, that's the difficulty. You've got to have your graph roughly, you know, try and get it as accurate as you can. I know it's quite hard because it's not a straight line, but as best you can. Yeah, so I got that. What did I say? So the one I did was the pink one, right? I got 40. So I would, in my working out, I'd say, well, 40 out of 80 times 100. Again, they've chosen nice numbers because it's a non-calculator. That's obviously 50%, isn't it? So I worked out that 50% is actually 50% of people have a weekly wage less than 360. And he said 60%. So is he correct? You have to say yes or no. It's obviously no. But as you said, you could go the other way around about it. You could work out 60% of 80 and then figure out how many pounds that is and go, actually 60% is 380 pounds. So again, he's still wrong. So it doesn't matter which way round you do it, whichever makes sense to you. Either way, you should get the answer no. He is not correct. And that was 3 marks, actually. That was quite good. Okay, oh yeah, so here we got density. This is the one I mentioned earlier. You do need to know the formula for. As you can see, they haven't given it to you. So liquid A and liquid B are mixed to make liquid C, and then they've given you some information about both. So we've got the density and the mass of A. We've got the density and the volume of B. Work out the density of C. So what I do is, this is our formula triangle. For density, it's always, yeah, exactly, mass over volume. So mass is at the top, density is here, volume is here. The reason why I use a triangle is because I tend to need to work out different things throughout, so I like to use a little triangle. So, do you see how for liquid A, we've got density, we've got mass, the only thing that's missing is the volume. So I'm going to work out the volume of A, which is obviously mass over density, so 70 over 1,400. You can see, again, they've chosen numbers that, yeah, they've chosen numbers that are nice. So I'd probably knock off that. Oh, I've done it the wrong way around. Do it the right way around, that'd be helpful. It's always good to have the triangle if you actually listen to it. Mass at the top, then we go with density, and then you can knock off those. 140 divided by 7, you could do 14 divided by 7, which is 2, and then add a 0, 20. So what was that? Volume, which is in meters cubed. Then I do B. What am I missing for B? We've got the density, we've got the volume, so do you see how I'm missing the mass in that case? So I can move, oh. Try and move this thing. Sometimes it works, sometimes it does not. There we go. Mass. So to find the mass of B, I need to multiply the density and the volume. So 280 times by 30, I just did 28 times 3 and added 2 zeros basically. So 28 times 3, if you add it, 60 plus 24, 84, then 2 zeros. So you should get 8,400 kilos for mass. And then, so for liquid C, we want the density, which is mass over volume. So the density of C is then, because they've mixed them together, you add them together, right? So the total mass would be the mass of A, which is 1,400 or 1,400, plus 8,400, mass of B, over the total volume. Now the volume for A we worked out was 20, the volume for B they said was 30. So do you see how you just work out both? So when I add it, we should get, what was that, 9,800 I think at the top, and then over 50, I knocked off 0. Dividing by 5 is the same as dividing by 10 and then doubling it. So I divided by 10, which is 98, and then I doubled it, which is 196. That's how I divide by 5. Oh, it's the first paper for your finals. Well, best of luck. I hope it goes really well. And I'm sure you'll feel much better once it's over. You can have a sigh of relief after that one. At least you can tick one off. Okay, question 14. Got some probability now. Sally plays 2 games against Martin. In each game, Sally could win, draw, or lose. So we've got 3 parts there. In each game they play, the probability that Sally will win against Martin is 0.3. The probability that Sally will draw against Martin is 0.1. Work out the probability that Sally will win exactly one of the 2 games. Now, I like to set this up as a probability tree. Again, you don't have to, but I just like to. I like to see it visually. So there's 3 options. So the first game, win, lose, or draw. We've been told win is 0.3, well, draw is 0.1, so then lose is 0.6. You can work that out because it has to add up to 1, doesn't it? Then the second one, we don't really have a lot of space here, but anyway. Win, lose, draw. Now, they haven't mentioned any other probabilities, so they are just the same, right? If they don't give you enough information about it, then you can just assume that they are the same. Probabilities, I'm gonna run out of space here. Win, lose, draw, 0.3, 0.6, 0.1, and then the last one. And then I just highlight or somehow identify, right, the options that satisfy the question. So it says work out the probability that Sally will win exactly one game. So she could win the first one but then lose the second one, but she could also win and then draw, but she could also lose and then win, or the fourth option is she draws and then she wins. So those are the 4 options. So I need to work out all those probabilities. Now, between the branches of a tree, you multiply. So for the green one, 0.3 times 0.6. For the yellow one, 0.3 times 0.1. For the blue one, 0.6 times 0.3. And lastly, for the pink one, 0.1 times 0.3. Now you can see they're basically 2 of the same, so luckily you don't have to do too many. It's drawing 3 tree diagrams necessary after the main one. Well, yeah, you could just draw the 2 that you know are going to be relevant. Like, I don't know if that's your question. As in, for this win here, you could then just draw, lose, or... You could just draw, lose, or draw. And because you know you can't draw win again. So you could, like, ignore that branch. For this one, you could go, well, I know it can't be any of the others. It has to be win. Yeah, you don't have to draw the whole thing if you know which branches it's going to be. That would be fine. Because they're not going to mark you on your tree, they're just going to mark you on your working, if that makes sense. So we didn't actually get a question, I don't think, on multiplying decimals in this paper, but they put it here. So multiplying decimals, just be really careful. When you multiply decimals in terms of 0 point something, they're going to get smaller. So it is 3 times 6, but it's 0.18. Okay, so don't put like 1.8. Think about it in terms of a context. Probabilities always have to be less than 1, so that gives you a bit of a clue. Now this one, 0.3 times 0.1, has to be smaller again, so that's 0.03. And then the other 2, I know they're multiplied in the opposite direction, but that's the same thing, isn't it? So you only have to do 2 calculations, basically. But just be really careful with the decimals. Oh, that was meant to be a 3. Now, once you've got multiple options on your tree, you always add them together. So add those up, you should get 0.42, which again is less than 1, so that's valid. And that is your answer, 0.42. Now, I've got it as a decimal. I would assume they would accept it if you put it in a different format, but as long as it's equivalent. Yeah, they said or equivalent. So if you put 42%, that's fine. If you put 42 over 100 as a fraction, that's fine, but I don't know why. Like, I just left it as a decimal. Okay, this one is an ideal question. Really just straightforward. There's nothing weird about it. As long as we know how to do equations of straight lines, this will be really easy. So the straight line L1 has equation y equals 3x minus 4, and then the straight line L2 is perpendicular. This comes up quite a lot in is it not 0.45? No, it's not 0.45. Oh, where did you get the 0.009 from? Hang on, let's go back a sec. That's what you should have, those 4 different calculations, and then those add up to 0.42. Yeah, so you've multiplied win and win together, right, to get 0.09, but they said that she has to win exactly 1. She can't win both. So 0.09 wouldn't be an option. Like, because that's like win-win, isn't it? She can't win both in this case. They've asked us to work out the probability that she wins only one of them, and then the other one would be either a draw or a lose. I think it looks like you've worked out the probability of her winning both and then losing both. Oh, I see what you're saying. 0.3 plus 0.3. Yeah, no, 0.03 plus 0 is 0.6. Oh, it's because you've multiplied it when you said add. No, yeah, no, I think he's got this far. I just think he added it up wrong. That's the only thing. Because, yeah, you got 0.36 from adding up the 18s, right? That's fine. But 0.03 plus 0.03 added is 0.06. So then it would add up to 0.42. So you were right, as in your original working out was fine. Okay, that's fine. Yeah, that's fine. Your Pakistani degree is valid in the UK. That's not something I would really know about, to be fair. I don't know. I mean, it depends if you're doing international ones, I guess. You know how you're doing I'm guessing you're doing the international GCSE, so then that would be valid because it's the international version. But I don't know if your degrees are kind of like the same thing, if it's like an international course or if it's just one that's like literally just a Pakistani university degree. In which case, I'm not sure. Yeah, I wouldn't know the answer to that, to be honest. Okay, so as I said, this is just working out perpendicular lines. So straight line L2 is perpendicular to L1. That comes up quite a lot. And passes through the 0.95. So this is a really straightforward question because they've given you all the information you need and there's nothing kind of complicated about it. We just need to know step by step. So straight line graphs are always y equals mx plus c. That's our kind of starting point. Therefore, I need to work out the gradient, which is the m, and then the plus c, the y-intercept. So I normally try to work out the gradient first. Now, to work out the gradient, you normally... Yeah, exactly, you're right, Akram. Normally, you need two sets of coordinates. Now, if you can see, we've only got one for that line, so we can't do that. The other way to do it, as you said, is negative reciprocal. So we're going to look at the gradient of the previous line. Now, luckily, they've written it already as y as the subject. If they don't, like let's say that was 2y, you'd have to rearrange it first, okay? But you can see here that the gradient of line 1 is 3. So therefore, like you've both said, we need to do the negative reciprocal. We need to flip it and make it negative. So that would be minus 1/3. Exactly. Now we're going to take that, rewrite my y equals mx plus c. Obviously now I know what m is. And now to find the plus c, all we need to do is sub in the other set of coordinates that we haven't used yet. So obviously make sure you sub them in the right way around because it can be kind of easy to just put 9 first and then 5, but obviously it's not. It's 5 first. This is where you've got to be happy with multiplying fractions and whole numbers because obviously non-calculator. That's basically 9 divided by 3, isn't it? Minus 3. And then add the 3, which is 8. There we go. So then you just write out your answer. Minus 1/3 x plus 8. That one's really nice and straightforward, that one. Guaranteed marks, I think that one is, isn't it? Okay, question 16. This is a topic that doesn't often come up, but it is really easy when it does, if you can just memorize a formula. So it's quite rare, but then when it comes up, it's just guaranteed marks. So Shirley wants to find an estimate for the number of bees in her hive. On Monday, she catches 90 of the bees. She puts a mark on each bee and returns them to her hive. On Tuesday, she catches 120 of the bees and she finds that 20 of these bees have been marked. So this is called capture-recapture. It's a very small topic. It could be any kind of animal, right? But they will either mark them or sometimes they say they put a tag on them or something like that. It's all the same context. They catch something, they mark it or they tag it, they release it again. The next day they recatch it, count how many have the tag or the mark. So estimate the total number of bees in the hive. So you just need the formula, which is the... doesn't really matter about. I think they use n, but it doesn't really matter. Anyway, that's the estimation. Is equal to, what you need to remember to do is, it's kind of normally in the order they write it. So it's the number that she caught the first time, multiplied by the number she caught the second time. So the recapture. over the number that was actually marked the second time. See how it's basically in the order that they've written it? Actually, it's kind of easy. And then you want to work that out. So yeah, or you could write it like that and then rearrange it. That's all. It depends how you've memorized the formula. Yeah. So to work this out being non-calculated, I'd probably knock off the zeros just to make my life a bit easier. 9 times 12 is 108 over 2. No. Yeah. No. What have I missed here? That's too small, isn't it? How does that not work? And 9 times 12 is 108. Ignore me. I think I did it differently when I worked it out myself. I don't know why that didn't work. Go back. Anyway, 9 times 12 is 108, and then I think when I actually worked it out on the piece of paper, I'd put 2 zeros because of the 90 and that one. Oh, because I knocked off a 0 on all of them. You can only knock off 1 0. That's why. If it was plus, then you could knock off the 2 zeros. So if you want to knock off the 0, you can only knock off 1. Then it works. I was thinking that's too small the scale. Anyway, here, then I knocked off a 0. This is how I did it when I went through it yesterday. And then obviously you should get 540, not 54. 540. However you want to obviously mathematically work that out is fine. And then, so that's pretty much guaranteed. Like if you just memorize that formula, you'll get the question every time. That's 3 marks. That's quite a lot of marks really for something that's quite straightforward. Then often there's this part B. So Shirley assumes that none of the marks had rubbed off between Monday and Tuesday. If Shirley's assumption is wrong, so let's say some of the marks have rubbed off, explain what effect this would have on your answer. So if some of the marks have actually rubbed off, then it would mean that the 20 should technically be higher, shouldn't it? That would be a bigger number. So think about your calculation. Therefore, I would be dividing the numerator by a bigger number, so therefore my answer would be smaller. So you just need to say something like there would be fewer B's, or the number of B's would be less, or the answer would be less, or, you know, something like that. Our amount will go down, some kind of synonym of that. So I would say there would be fewer B's is probably what I would say. As long as you say less. If you say more, then obviously it's wrong, right? As long as you say less, then that's fine. Sometimes the part B is actually what assumption have they made? And then you would say basically this sentence here. You would say we have assumed that none of the marks have rubbed off, or if they said tags, we've assumed that none of the tags have fallen off. Sometimes that's a part B, so just consider that as well. But that's a really nice easy 4 marks, I think, if you've got that formula. Okay, question 17. This is another topic, kind of a niche question, but I call it rearranging equations, but like for higher tier. This is kind of a more specific one. I think we saw this in maybe yesterday's paper or another of the papers. So it's when you want to make something the subject, but you see how that same letter appears twice. That's what I mean. So make F the subject of the formula. You can see F appears twice. So it's quite a specific way to do it. Obviously, I want to get rid of the fraction. That's kind of annoying. I need to open all of this up. So I'm going to multiply across by F minus 4. So that would be df minus 4d. And then I'm going to also expand out the bracket. So everything is just out. Then you want to get, yeah, it was yesterday, right? Then you want to get, obviously, whichever letter you're looking for on the same side, everything else on the other side. So I'm going to move it to the left because I think that would make everything positive, which is a bit nicer, isn't it? So add 3f, then I'm going to add 4d. And luckily, in this case, everything is positive. If you moved it to the other side, that's also fine. You'll just end up with those are negatives, but it is still correct, if that makes sense. Now, this is the bit that you just have to memorize what to do. How do I get the f like on its own, just one of them? I need to factorize it out. If you memorize how to do that, then it's really easy, but it's kind of it's not really a logical thing to think to do, I don't think. Because you're just used to adding, subtracting, multiplying, dividing. We're not used to thinking of factorizing, but that's how you'd get the f on its own. And obviously your last step is then to divide by that whole bracket. It doesn't matter if the other side is really messy, if it doesn't look that nice. The whole point is just to get f on its own. So You should get that. You might have, if you've swapped it to the other side originally, you'll probably just get a negative version of this, but that would also be acceptable. They've said or equivalent, so that's fine. So yeah, just remember to factorize. Okay, this is the one where I feel like you might find this one a little bit harder. It's proportion, but not in a straightforward sense, unfortunately. So they've said x is proportional to the root of y. Obviously y has to be positive, right? Because you can't square root a negative, so that's fine. Y is increased then by 44%. They've chosen that number deliberately. Work out the percentage increase in x. Now we don't have any numbers. So what you can do is just choose numbers. Normally when they don't give me numbers, but there's percentages involved, I might just choose 100 and use that and then see what happens. So what I mean by this is I'm going to set up the equation for proportion. I'm assuming this is direct, right? Direct proportion, because they haven't really specified otherwise, which would be x equals k root y. Now, we're not going to work out what k is. It's just technically it is just there, isn't it? So don't worry about the k. That's just part of proportion. We don't have enough information to work it out. What I did was I said, well, let me just assume let y equal 100, or you can choose another number if you want. So I said, okay, fine. If I sub in 100, which is a square number, luckily, that would give me 10k, wouldn't it, originally, before the increase. Now, let's look at the scenario where we've increased it by 44%. This is why I chose 100, right? Because increasing by 44% is easy. When you increase by 44%, it's going to be 144, isn't it? Which is why I was saying they chose the number deliberately, because that's also luckily a square number. So then I went, okay, let me work out what that would be. Well, that would be 12k, wouldn't it? And then just compare them. The k doesn't really matter. The k is just a multiplier, so just ignore the k. What has happened to x? What is the percentage increase from 10 to 12? That's 20%, isn't it? Do you see how that's increased by 20%? Yeah, it's kind of a hard question. Because they haven't given you numbers. You don't have to do it this way. You don't have to use numbers. You can use decimals if you want, but I feel like that's worse. Because if you square root 100, the square root of 100 is 10, isn't it? And then obviously I wouldn't write k10, because mathematically you would write the number in front, wouldn't you? Yeah. It's just because I've square rooted it. The same over here. I square rooted 144 and I got 12. I just put it in front of the k because obviously it's the coefficient, isn't it, technically? So the k technically goes at the end. That's the only reason. I mean, you could probably do it without even writing the k. I just wrote the k because technically, the proportion formula for direct proportion is k times by whatever the thing is. In this case, it's root y. When it's inverse proportion, it's like k over. In this case, it'd be root y. If it was inverse, that would be it, wouldn't it? But it's not. I'm assuming it's direct because they haven't specified that it's inverse. That's what I did. Whenever they use percentages but don't actually give you numbers, I just put in a 10. Because think back to percentage change. You know, you said there's that formula for percentage change. That's what they're asking for, isn't it? Obviously, they're saying it's an increase, but it's still a change, isn't it? So what you can do is what has changed here. Again, just kind of ignore the k's, right? Because so percentage change is the change, so that would be 12k minus 10k, wouldn't it, over the original, which is 10k. Do you see how if I were to simplify that, obviously times by 100, you'd get 2k over 10k, which first of all the k's would cancel anyway, wouldn't they? That's why I'm saying ignore the k. The k doesn't really make any difference, does it? Exactly. And then you get 2 over 10, which is 0.2, which is 20%, or 1/5, which is 20%. Do you see what I mean? That's why I chose to use a number originally, because I could see my starting point was 100%, and then now what is it? It's now technically 120%, which is a 20% increase. You can obviously start with any number you want, but I just like to use 100. Would you get the mark if you left it as decimal? It does say percentage, so no, I don't think you would. Because you see how they put a percentage here? That I'm assuming you put 0.2. If you put 0.2 here, they would assume that you meant 0.2%, which it's not, it is 20%. So in the mark scheme, they have said it has to be 20. That's just the answer. They haven't given an option for anything else. Because of the fact that they've asked for a percentage. Yeah. For 17, yeah, hang on. I can scroll back. Oh, why has it zoomed? There. This is the answer. 4d plus 3 over d plus 3. Yeah, so just be careful with how you leave your answers, because if they've asked for a specific thing, then that's what they will be looking for, which in this case they asked for a percentage. Yes, that's exactly the same. That's fine. Because if you do 3 plus 4d, well, did you put d4 or 4d? Because the coefficient should technically always be in front of the letter, right? I don't know if they'd be fussy about that, though. Well, technically, you should always put the number in front of the letter. Like, d4 doesn't really mean anything. So, it doesn't matter that the 3 is in front of the 4d, that's fine if you swap those, because if you add them whichever direction, you'll still get the same answer. But I would recommend making sure that your coefficient, so the number is the coefficient, right, is always in front of the letter. That's just how algebra works generally, right? So I think, I mean, they haven't even written anything about it in the mark scheme, so I don't know if they would accept that, but I would fix that if I were you, just in case. It is like, as in d times 3 is still the same as 3 times d, like the answer would be the same, but in terms of writing something correctly algebraically, you always put the number first. So like, it is technically the same thing, but I would never write it that way round. It's like when I did the question 18, I put the 10 in front of the k. Because k times 10 is still the same. It is still the same thing, but like, algebraically I would write it. Make sure you just put all the numbers in the front. Yeah, so that's what I'm saying. You can use any number. I just used 100 because it was percentages, and I feel like 100 is quite a nice base to use. But yeah, you could use a different number. Do you have a number that you used? As long as you obviously calculate the percentage, as long as you get 20% at the end, then that's fine. As long as you calculate it properly. I think the only difficulty might be that if you used a different number that wasn't a square number, that could be more complicated. So because it's the square root, so like if I used 50, I wouldn't know how to square root 50. I feel like that could make it harder. So I guess in this case, using square numbers was also quite helpful. And then I worked out 44% increase of 100, which was quite easy, wasn't it? You just add 44. Whereas if you used a different number, it might be kind of hard to figure that out. So yeah, you can use different numbers. It might just be a little bit harder to figure out because you don't. This is non-calculator, isn't it? If it was a calculator exam, it really wouldn't matter. You'd be able to figure it out anyway, any number that you used. So yeah, if you found another number that worked quite well, and you still got 20%, then that's fine. You don't even have to use numbers. I just used a number because I thought it was helpful, but you can do it without even using numbers, as in without using inputting a number for y. You just end up with like coefficients of y, but then you end up with decimals and you have to square root a decimal, and I feel like for some people that might be more confusing. So yeah, as long as you get 20%, I'm sure it doesn't really matter how you got there, unless you guessed, in which case they might not give you the mark for the working if you just guessed 20%. Okay, question 19. Functions seem to always come up on the non-calculator. I say always, I mean, you know, quite a lot of the time. So that's another one to kind of focus on for your non-calculator, I would suggest. So f and g are functions such that you've got f of x is 12 over root x and g of x is 3 multiplied by 2x plus 1. First of all, we've got what I'd call just like a normal function, as in just sub in the 5 to the g function. So you've got 3 times 2 times 5 plus 1, so I just worked it out as that's 10 plus 1 is 11 times 3 is 33. You just sub it in, that's really nice and easy, that one. And then part B, we've got a composite function. So that's the one where you sub it in backwards. So in this case, it's f into g. F into g. Just remember which way around it is, depending on how they write it, is backwards. Now you've got two options here. You can work out the composite function by subbing f into g, and then at the end sub the 9 in if you want. What I tend to do is I just sub in the 9 initially to the f, and then I sub that answer into g. That's just what I do, but again, it's up to you. So that would be 12 divided by 3, which is 4, and then I take the 4, obviously don't forget to then take the 4 and sub it into g. That's what I would do, but you can do either of those options I just mentioned, it's fine. So that should be 27. For part B. And then we've got an inverse, so hang on, let me just write down what g was originally, because we can't see it. G originally 3 times 2x plus 1. Now, the only thing with doing it the way that I did in the previous one is you can't do the same for the inverse. You can't sub the 6 in and then invert it. You have to invert it first, then sub the 6 in at the end. Yeah, I can show you the other way. Just because you might prefer to memorize the other way because then it's consistent with part C. Yeah, it's effectively a function machine, I guess, isn't it? So the other way is just taking the whole, so ignore the 9, take the whole of G, take the whole of F and put it into G. So when I say put it into G, I mean wherever there's an X. So you would get, so G of F of X, you would get, obviously start writing the G function as normal, but then when there's an X, instead of X, you write the whole of F. So that would be 12 over root x. Do you see why I didn't do it like this? Just because it's a bit more messy. That's that, and then maybe you might want to expand it, I guess. So 2 times 12 would be 24. 3 times 24 over root x. So root plus 1, and then you might want to expand it. Or you could sub the 9 in at that point if you wanted. Then you can sub in 9. So you get 24 divided by 3, which is 8, plus 1, which is 9, times 3, which is 27. You see what I mean? You could do that first and then sub in the 9 at the end if you prefer. It doesn't matter, it's whichever you prefer. So this or this, whichever option just makes more sense to you. Now, that second option is more consistent with how we have to do the inverted one, so you might prefer to just stick with one method for both, rather than thinking of two different methods, if that makes sense. So I'm going to invert it first, then I sub in the 6 at the end. So the way that I do inverse functions is instead of g of x, just put y there, just for simplicity. Now, again, there's two options. Some people like to swap the x and the y now, and then make x the subject again, which then gives you a direct answer. Or the way that I just always did it was I made x the subject now, and then swapped it at the end. So you're either going to swap x and y now or at the end. It doesn't matter, again, really doesn't matter, it's whichever makes sense to you. I like to swap it at the end just because that's how I learned how to do it. So I would probably actually expand this first. I don't think I would divide by 3 and then divide by 2 again, because then you get a double fraction. So I'd probably expand it first and then start rearranging. So obviously minus the 3 and then divide by 6, which equals x. Now you see how now though I do need to swap it. So I'm going to swap it. So the inverse function of g is x minus 3. As long as you get x minus 3 over 6, you don't obviously want to have y at the end of it, do you? It's just there as a placeholder. Now I can sub in 6. So 6 minus 3 is 3 over 6. So 3 over 6 simplifies to 1/2. Now, the answer is 1/2. If you left it as 3 over 6, they will also accept that because they said or equivalent. 3 over 6 is an equivalent. They haven't told you to simplify it. Technically, the official answer is 1/2, but if you put 3 over 6, that's also fine. Okay. So yeah, 5 marks, 33, 27 and 1/2. Perfect, I'm glad that was helpful. Okay, question 20, we've got some surds again. Again, this one is quite commonly put in the non-calculator. So show that root 180 minus 2 root 5 over 5 root 5 minus 5 can be written in the form a plus root 5 over b, where a and b are integers. So that means a whole number, right? That's your clue. You said you missed so much. I don't know if you mean of the live, in which case you can go back and watch it later. That's fine. But if you mean so much in terms of content, then yeah, I don't know what to do with that. How to help you with that, but you can always obviously rewind and watch it again. So this one, they haven't said it in the question, but the implication is that we need to rationalize the denominator, because you see how their fraction doesn't have a surd anymore in the denominator. So that's basically what they're saying. If you ever get fractions with surds, it's pretty much rationalizing. Now, again, there's like a million ways to do this. Exactly, that's your question. There's a million ways to do this. You can rationalize it first and then simplify after, or you can simplify whatever there is that might be simplifiable first and then rationalize it after. I personally would simplify as much as I can first, just to make then the rationalizing easier, but it's up to you. So yes, I personally would simplify the 180 first. That's just me though, you don't have to. But it's just because I don't want to have to deal with multiplying 180 by numbers when I don't have a calculator. So simplifying surds, we need to find two factors of 180, but obviously one of them has to be a square number. Now, this one I think has multiple options, multiple square number factors. So if you get one but it's not the biggest one, it's not the highest common factor square number, then you'd have to simplify it twice. Well, yeah, so 90 and 2 are factors, but neither of those are square numbers. So you can't use 90 and 2. It has to be one has to be a square number. So technically you could use 9 and 20, but then, I don't know if you know, but 20 would also simplify further, wouldn't it? So you can use 9 and 20, but 9 is not the biggest square number. No, 90 is not a square number. So actually the biggest square number is 36, which is probably kind of hard to figure out that, to be fair. So if you do end up simplifying it twice by doing 9 and then simplifying again, that's also fine. Technically 36 is the biggest by 5. The other clue is that, you see how all the rest of them are root 5s and the answer is only root 5? So it's a bit of a clue that maybe if I divide 180 by 5, maybe the other number is a square number. So you could use that logic. Exactly. So that's what I would simplify it into. Obviously that would square root to become just 6, so I'm just going to write it as 6 root 5 for now. Minus 2 root 5. Now, if you know surd rules, when they're the same surd, you can actually subtract them. So now the numerator, instead of being two separate terms, you can actually subtract to make one term, collect the like terms. If you think about algebra, it works the same way, doesn't it? So that's why I think simplifying is worthwhile doing it first, because that ends up being 4 root 5, just as a single term. So now the numerator is much easier. Now I'm going to rationalize. Now because the denominator has two terms, it has obviously a surd term and then another term, we have to do kind of the logic of difference of two squares. So you multiply by the denominator, but remember when there's two terms you have to change the symbol, so that is a plus in this case because the other was already minus. Now because it's a fraction, you have to obviously multiply the numerator by the same thing that you multiply the denominator, which is why I didn't want to have to deal with root 180. I didn't want to do 180 times by anything because then it would get much bigger and I just didn't really want to deal with that. So that's why I simplified it first. So it's effectively like the numerator's kind of like, well, it is single brackets, isn't it? You can obviously expand it straight away. You don't have to write it out like this, but I'm just kind of writing it so you can visualize it. And the denominator is obviously double brackets. So just be careful when you're expanding which numbers are whole numbers, so the numbers on the outside, and which numbers are surds, because they obviously can't mix. So the first one would be 4 times 5 on the outside, which is 20, but then on the inside of the surd, 5 times 5 is root 25, which you might be quite happy to just go, yeah, but root 5 and root 5 cancel each other out. So you might be happy to just write it straight as 5. It doesn't matter. I mean, it's up to you. Again, there's so many things that are just down to what makes sense to you personally. So the second one though, see how it's 4 and then there's this over here is just a 5. So that would become 20 and then still the root 5 would stay there because there's nothing to multiply it by. Now the denominator expands in the same way as difference of two squares, so you don't necessarily have to write it all out, but I'll just write it so you can see what happens. So again, 5 times 5 on the outside, root 25. Root 5 times root 5 cancels to become just 5. or root 25 if you want to write that. Now you can skip right in the middle bit if you want to, but technically it is plus 25 root 5, and then the other middle bit is then minus. This is why we needed a plus and a minus, because we want those to cancel each other out. But just be careful with this last one, because that's a minus, isn't it? Minus times a positive is minus 25. But do you see how the whole point is that those cancel out, become 0, and then the rest of it, do you see how the rest of the numbers in the denominator are no longer surds? Which is what we want. We want to rationalize it. We don't want a surd in the denominator. So the numerator is 100 plus 20 root 5, and the denominator is 125 minus 25, which is 100. So we have rationalized it, but now, obviously look at the format that they want you to leave it in, and you need to figure that out. So you can split fractions. If there's a plus or a minus, you can split them. So it's kind of like 100 over 100. And then 20 root 5 over 100, which you can see that's why you end up with just a whole number on the first one. A is just 1, isn't it? And then B would be root 5 over 5. So that's your final answer. So yeah, different ways to kind of do this in different orders, but as long as you end up with this as your answer, then you have done it correctly. Okay, we have 3 more questions. How did I split it? What, this bit here? That's just a mathematical fact. That's just, it's just, I knew that you were allowed to do that. How did I get the 4 in the denominator? Oh, the 5. Right, so I split it because you just can, I don't know, you're just allowed to do that, basically. Also, if it's a minus, you would just put a minus in the middle here, right? You can split, because you're basically dividing the 100 by 100 and then the 20 by 100 still, so it's the same thing. I just split it because in the answer format, they had split it. So I thought, yeah, I need to split that as well. 100 divided by 100 is obviously 1. And then this bit here, to get the 5 in the denominator, again, you've got to kind of keep the surd and the whole numbers separate. So when you're dividing, just think of it as 20 over 100. You could make that, if you knock off those zeros, that would be 2 over 10, wouldn't it? And then 2 over 10 is the same as 1 over 5. So do you see how that's where the 5 came from? Hopefully that answers your question. Obviously, I still have the root 5. That didn't go anywhere, did it? So that's still in the numerator. It's just simplifying the fraction, basically. You should get 5. Yeah, okay, perfect. All right, question 21, we now have vectors, but this is actually quite a nice question, to be honest. This is not one of those really bad questions. It's only 4 marks, this one. So DEF is a triangle, P is the midpoint of FD, and Q is also the midpoint of DE. FD is A. Sometimes they don't label it, so obviously you want to label it yourself. So FD is a whole. The whole of that one is A. FE is B. Use a vector method to prove that PQ is parallel to FE. So FE, yeah, I know you said not vectors, but like this one's not bad, I promise. Yeah, the ratio vectors is the problem. That's the one that's really hard, and I do have a video on that. Yeah, you're right. F to P is half of A. Yeah, I do have a video on the ratio one, so you can have a look at that separately, but this question doesn't need that, luckily, so this is a nice one. Whenever you're trying to prove that 2 vectors are parallel, or that they lie on a straight line, it's the same thing, you obviously want to find the vectors for those 2 lines, so that's step 1. First of all, we already have FE, so that's fine. So we just need to find the vector PQ. And then the second thing is that we want to show that one's a bigger version. Yeah, it must be a multiple, exactly. So we just basically need to find PQ, which is quite easy. Even if you're not sure what to do, just start writing down any vectors you can figure out is my recommendation for vector questions. Because normally that's the first mark or maybe 2 marks. So P to Q, I basically went, you can obviously go back all the way down, but I went up to D and then down to Q. So as you were saying about F to P is the same thing as P to D, isn't it? This is a half A because it's half of the line. But then D to Q, before that we need to know the whole of, what was it, DE, don't we? So first of all, you need that one. So d to e would be back down, so that's minus a plus b. There's always some kind of minus a plus b, isn't there? And then so therefore half of it, because that's d to q is only half, isn't it? Is a half minus a plus b. So p to q is a half a to get up to d, and then from d to q, which is in the correct direction, is half minus a plus b. Now obviously I'm going to expand and simplify this as well. So expand all of that, simplify it, collect the like terms, all of that stuff. Oh, that's a minus, isn't it? Be careful of the negatives. Minus a half a plus a half b. Did you see how the a's would cancel? So that's just a half b. Now they already gave us fe, didn't they? They said fe is b, 1b. So you just need a little conclusion now. You don't have to write a whole sentence again. The way that I lay it out is I put the bigger one, so fe is the bigger one, isn't it, is equal, and then whatever the multiple is, so I wrote 2 times pq. You could write it the other way around if you wanted. You could write down a half fe equals pq. That's also fine. Whichever of these makes more sense to you. So that shows that it's a multiple. That's the bit that kind of implies that it's a multiple. And then I put therefore, that means it's parallel. Like I don't even write a whole sentence or anything. But as long as you've not just stopped here, you have to show that they're multiples. You could even write down that they are a multiple. One is a multiple of the other. You could write down fe is a multiple of pq. Any kind of version of that. I like this because it's not really using words, but that's just me. As long as you put that conclusion, that's your final mark. So even if you got this far and you weren't sure how to prove it, that's still 3 out of 4 marks, right? That's 3 out of 4 up to this point. The only final mark is to show that it's a multiple. So yeah. I think the multiple ones, the parallel ones are quite nice. And if you want to prove it's on a straight line, you just have to prove, first of all, that it's parallel in the same way, and then also that they share a point in common. Sometimes they share like point A or something. And so obviously if you have 2 parallel lines, and if they both start from point A, then they must overlap, mustn't they? They must create a straight line. Yeah, so it's either this that's proving parallel or the ratio one, as you said, which I think we went through in another session, didn't we? Did we do that Sunday? We went through it in a Q&A session, and that's the one where you just basically do simultaneous equations. Now, obviously, there could be other questions where they just say, work out this vector, but then I think those aren't as hard because you're just trying to figure out a vector. So yeah, I don't know, it's a bit hit or miss, really. It just depends how they feel on the day with the questions, isn't it? Okay, question 22. This is quite a big one algebraically, so we'll try and fit it all on. It is a 5 marker, this one. So the diagram shows 2 shaded shapes, A and B. Shape A is formed by removing a sector of a circle with radius 3x minus 1 from a sector of the circle with radius 5x minus 1. You can see they've just added 2x and 3x minus 1 to get 5x minus 1. Shape B is just a circle with diameter 2 minus 2x. They've obviously done diameter deliberately. Yeah, I mean, if you're happy with algebra, I don't think this is that bad. It just depends how confident you are with algebra. I think 23, it's only 3 marks, but it doesn't really, I don't think that makes a lot of sense, 23, so that one's not so great. So yeah, they've done the diameter deliberately, so just remember that you're probably going to have to half it. The area of shape A is equal to the area of shape B, find the value of x. So this is just solving equations, but it's just a massive equation. That's the only thing. So it's just setting up the equation. The area of A is equal to the area of B. So obviously the area of A is slightly more complicated, but they basically told you, work out the whole sector and then subtract like the white sector bit. So obviously you need to know the formula for the area of sectors, which on your formula sheet, they do give you the area of a circle. You just have to kind of apply it to this. Yes, you're exactly right, Akram, exactly. That's basically it. So the area of a sector, you do obviously pi r squared, so I'm going to do the bigger one first, right? So pi times the radius of the big one is, the big sector is 5x minus 1. Now that's squared. Don't forget to square that. and then you times it by the proportion of the circle you've actually got, which is 45. You always use the angle over 360. And then you minus the smaller one, which is exactly the same, but obviously the radius is now 3x minus 1. 3x minus 1, don't forget to square it, times by the same. They both have the same angle, don't they? So that's the left-hand side of your equation. Now, obviously, you then need to put that equal to the area of shape B, which is just a circle, pi r squared. But as I said, don't forget that they've given you the diameter. So in terms of radius squared, we need half of that. So it'd be 1 minus 1x, or just 1 minus x, obviously. And then that's squared. So that's my equation. You just have to set that up. Obviously, as you can see, we now need to solve it, which is the bit that's just kind of long, basically. So, I mean, the first thing you can do immediately if you want is just knock off the pi's, as in, I don't mean literally knock off, I mean if you divide by pi, because all three terms in the whole equation have pi, you can just cancel it out. So don't worry about the pi's, we don't need to worry about that. You probably simplify the 45 over 360 as a fraction. They normally choose an angle that would simplify, and that simplifies to 1/8, both of them. So 5x, we got basically 1/8 times 5x minus 1. These are double brackets, aren't they? Minus another 1/8, 3x minus 1, 3x minus 1. And then I'll probably expand out these double brackets as well. 1 minus x, 1 minus x. So it's just a lot of expanding. Instead of timesing by 1/8, what I did was I just kind of multiplied both sides by 8, but you can expand it however you like. So I put the 8 on the other side. But let's expand this. So 25x squared minus 5x is minus 10x. And then don't forget that that is a plus 1 at the end, plus 1. And then this is minus, so kind of like that other one we did with the, what was it, the indices, the index laws, you know, when we were subtracting 2n minus 2, this is the same thing. I'm going to put it in brackets so that I remember at the end, after I've expanded it, that I need to subtract every term here. So that's the same logic. 9x squared minus 3x is minus 6x plus 1 again. Do you see how I need to subtract not just the 9x squared, but also the negative 6x and also the 1? So that's why I put it in brackets. And then here I've multiplied by 8. That was just me. That was my personal choice because I didn't want to end up with fractions. So it's up to you if you want to do that. Expand it. We've got 1. Be careful with the symbols here because I think I got this one mixed up when I did it before. Plus x squared. It's not negative x squared. It is plus x squared. So now on the left hand side I'm going to subtract. So 25x squared minus 9x squared is 16x squared. But do you see how for the 6x it's already negative? So I'm subtracting a negative. So that's double negatives, isn't it? So that's minus 10 plus 6. So just be really careful there. And then 1 minus 1 just cancels, doesn't it? It's not there anymore. And then here, obviously, if I expand that, 8 minus 16x plus 8x squared. Now, because I've obviously ended up with a quadratic overall, I'm going to move it to the side where I have a positive quadratic. That's what I like to do. So if I moved 16x squared, you see how that would become negative x squared. So I'm actually going to move all of the right to the left, even though it's more terms. I would just rather keep it all positive, as in, well, at least the x squared I'd rather keep positive. So that's my choice. So take away 8 gives me not a 1, gives me 8x squared, so still positive. And then I added 16, so that gives you plus 12x. I want to make sure I'm not getting this wrong. Yeah, plus 12x. And then I took away 8, which is then obviously make it equal to 0. This is the second to last question. So we've got this question to finish. The last one is 3 marks, so probably 10 minutes more, 10-15 minutes more. What did I get in Maths GCSE? Maths GCSE, well, I did it so long ago that it's not numbers, right? I did it and I got an A star in GCSE. I did it in A level, I got an A, and then I didn't do it at uni because I thought that was probably enough. So I didn't do maths at uni, I did something else. So we've got a quadratic. Now you can obviously factorize it now if you want, but I noticed that, do you see how you've got 8, 12, and 8? If you can simplify a quadratic before you factorize it, that's always going to be helpful. So all of those terms, the 3 terms, are divisible by 4. So I just divided everything by 4, just so that when I factorize it, it's a little bit easier. That's not 4. That's 3. And then that's minus 2. Do you see how this is now much easier to factorize? So I always look out for that on these big questions that have quadratics at the end. Can I simplify the quadratic? So factorize. Next, luckily we've got prime numbers. So 1's plus, 1's minus. We obviously have 2 and 1. So we're going to have to do 2 times 2 to make 4, and then 1, which makes 3. So plus 2 minus 1. I didn't do further maths at A level, right? I only did maths. So I don't know if further maths is easier. Because I didn't do it. I would say maths at A level is hard. Like, you do get used to it, but it is a jump. I mean, I think that's the same with all A levels. They're all a jump. It is somehow significantly harder, and it's a lot of very different things. Like, you're gonna learn a lot of brand new stuff at A level, and you're like, I've never seen this before. So yeah, really think hard about if you want to do maths at A level, because it is a commitment, is what I would say. I don't know if further maths is easier because I didn't do it. There is a further maths, not GCSE, I think it's called like level 2 further maths, and that is, it's not a GCSE whole qualification, but it's like you can do it at GCSE level, as in you can do your GCSE maths and do the further maths level 2 qualification. I guess it's similar to like half a GCSE or something. Now that's basically a lot of the same stuff you've done already in GCSE maths, plus a few things that they would do in the first year of A-level maths. So that's kind of like a bridge between the two. I don't know if you're referring to that or not, because that's not massively hard, that one, but I don't see why you would do that additionally to your normal maths. There's kind of no point. Okay, so obviously solve it. So we should get a half or minus 2. Now, again, when you've done these questions that have a context, do you see how they asked for one value? So we don't want, like, that's not your final answer. You then have to choose. Okay, so based on the context, normally with shapes, it's always the one that's not negative, right? So in this case, we've got a half or negative 2. Now have a look here, specifically at the 2x. I can't have a part of a length being minus or a negative, can I? Right, so I'm going to go with a half. It has to be positive, doesn't it? All the side lengths, based on a context of shapes, you have to have positive side lengths, so I'm going to go with a half. Yeah, there are new topics. It's kind of like an overlap. It just depends. So yeah, you've got differentiation, which differentiation is fine once you get used to it, but it is a brand new topic. So when you first see it, compared to what you've done at GCSE maths, it's like nothing similar to that. So you're probably going to be a bit like, whoa, what is this? Yeah, exactly. Matrices, functions, but not functions like in GCSE. Functions as in, it's like to do with domain and ranges, which is a completely different thing. Trigonometric identities, which is solving trigonometric equations, which you don't really have in the normal GCSE. Again, it's all stuff that you do get used to, but it is A-level stuff, what I would class as A-level. Yeah, matrices I kind of looked at recently and I was like, I've never seen this before. And that was me. I'd literally never seen it before. So I was like, what is this? Yeah, A-level maths is traumatic, is what I would say. So if you want to go on and do something and you need A-level maths for that in the future, then do it. If you don't need it and you don't feel like you're like guaranteed to get a 9 in GCSE, then maybe choose something else. I don't know. It depends what you're looking to do with your future, really. That's what it depends on. Yeah, it's hard to know because you might not know what you want to do in 2 years' time. I know that's also quite hard. You might not know what you want to do after A level. So yeah, it's difficult to to know. I didn't know what I wanted to do, and I was like, well, I liked GCSE maths, so I might as well do A-level maths, but it is hard. Yeah, exactly. The further maths is kind of an additional qualification, one that most people don't have anyway, or one that most people have never heard of in the first place. So yeah, obviously your main GCSE maths is the one that is the most important. So yeah, you want to work the hardest for that one, and then if you can also do further maths, then great. If not, then don't worry about it. I didn't even know further maths GCSE existed until literally like last year. So, you know, there's that. Okay, last question, 3 marks. So there are 4 types of cards in a game. Each card has a black circle or a white circle, or a black triangle or a white triangle. And as you can see, we've got ratios. So the number of black shapes to the number of white shapes, 3 to 5. The number of circles to the number of triangles, 2 to 7. So they're completely separate. Express the total number of cards with a black shape as a fraction of the total number of cards with a triangle. Now this one is one where I know that there's, I'm pretty sure, multiple ways to do it. So they've given multiple options. I guess it depends which one kind of comes to you first. Because they're looking for fractions, they're not looking for you to work out exactly how many there are. Actually, in reality, they're just looking for a fraction, so it'd be like a multiple of. So the way that I did it was I converted both of these into fractions themselves. So they've said, what do they say? Express the total number of cards with a black shape. So they want the black shape out of the ones with a triangle. So we're focusing on black shapes and triangles. So for the first one, the black shape as a fraction would be 3 out of 8, wouldn't it? Because you know when you convert any ratio into fraction, you take whichever side you want as your numerator. In terms of this one, we wanted black, so that's 3. And then you add it to make the denominator. No, yes, you have to add them to create the numerator, right? Because it's 3 and 5 parts, so out of 8 parts in total. And then the triangle one, same thing. So the triangle is the second one, right? So 7 out of 9. That's what I did. And then I went, right, okay, well, I want to know like I need to combine these somehow, basically, don't we? Yeah, we want to combine them, don't we? So I was just looking and thinking, right, well, now we're looking at 9 and 8. And what's the lowest common multiple of 9 and 8? Or just the two of them multiplied together, which is 72. But then obviously you want to change the numerators to reflect that as well. So the first one you'd have to times by 9, so that'd be 27 over 72. And then the second one you'd have to times by 8, which is 56 over 72. And now because they have the same denominator, I'm not saying that there's 72 cards, but there's obviously some multiple of 72, isn't there? Then we can create that into the fraction that they want. So they're saying total number of black shape cards divided by the triangle one. So it's kind of like this, isn't it? 72 divided by the triangle, and if you do keep flip change, then you'll get your answer. There's different ways to do it, different ways to look at it, but as long as you get this same answer that we're about to get, then it's fine. You can see here, obviously, you don't need to actually multiply it because the 72s will just cancel, right? So don't actually try and multiply it. You should get 27 over 56. I divided them because you see the wording of the question says, express the total number of cards with a black shape as a fraction of. When it says as a fraction of, it means divide. Let me just hang on, let me just read through the comments. Yeah, I guess it depends on the question whether you add. In this case, because I wanted to know black out of all of the cards, it was 3 out of 8, because that's out of all of it, isn't it? That's, I guess, depends on the question. Yeah, because I wanted to know it out of all of them, that's why I did 3 out of 8. I mean, most of the time it's out of both of them, I think. Most of the time, I would suggest. 3 divided by 8 divided by 7/9. Yeah, that's true. You could go directly into them. Yeah. You could just divide it straight. That's true. It depends kind of what makes sense in your head, I guess, doesn't it? That would make sense to you to just do it directly, then perfect, do that. Yeah, we divide them just because, as I was saying, because they've said as a fraction of, and as a fraction of is another way of saying divide, isn't it? Oh. You don't get the wording of the question. It's just because there's so many words. That's why I don't really like this sometimes. It's just too many words. So I kind of cross this out. So they're saying express the total number of cards, like the total black shapes, as a fraction of the total triangles. That's how I kind of translated it. So when they say as a fraction of, they mean that they want the black shape ones to be in the numerator, and then they want the triangle ones to be in the denominator. That's basically what it's saying. So that's the format. That's why I divided it, because this, I mean, this literally means divide, doesn't it? But as Akram said, he just straight away divided that. Yeah, ratio questions are really random. That's the problem, I think, with ratio, is it's just you can't really control what's going to come up or how it's going to come up, or if it's the same method every time. It's normally always different. That's, I think, the problem with ratio. So it's sometimes better to kind of focus on the topics that you can control, the ones that do present themselves quite similarly every time. Ratio and sometimes probability as well is a bit random. It's black over white. It's because I was just looking for black out of all of them. I wasn't doing black over white. I was doing black out of both of them, which is black and white, isn't it? That's why. I don't normally. Maybe I do the other type of question you're referring to when you do the black over the white. Maybe I do it a different way so I don't create that fraction. But whenever I make fractions, it's pretty much always just one of them out of both of them. So I always add them. I don't know. Maybe I do the other version of that question differently and I avoid using fractions. Oh, that's amazing, Akram. You got 70 out of 80. That's insane. That must be a 9. Hang on. Let's have a look. What was this, 2020? Oh, why don't I have that for 2020? Why don't I have the grade boundaries for 2020? I'll try and Google it. As we said the other day, the average grade boundary for a 9 is 65. So I'm assuming that you did get a 9 based on that. To the circle and the white when dividing. What was the circle and the white when dividing? They just weren't there, were they? I mean, as in, because I used these initially, the black out of all of them, because all of the cards have to be either black or white, don't they? And then also at the same time, all of the cards have to be circle or triangle. Hence why they've got this kind of mix here. So I just did 3 out of 3 black cards, or black shapes, or whatever it was. Black shapes out of all of the shapes. That's why I added it. So I wasn't even really focusing on the white ones or the circle ones. I wasn't really. Yeah, I guess this question is a mix of ratio and fractions, because you have to be able to divide fractions as well, don't you? Yeah, I just think that the circle ones and the white ones weren't really that relevant in this case. I mean, obviously you needed to know the information in order to create the correct denominator, but beyond that, I didn't consider it. Oh, you got an 8 on 2023 paper. That's really good because obviously that's a more recent paper, isn't it? So that's really good, getting an 8 on paper 2. Okay, right, so the grade boundaries, this is just averages, right? So obviously every year is different, so don't hold me to this, but this is like an average of the past few years since 2017 for Edexcel. So again, for maybe AQA it's different, right? Let me drag it over, hang on. This is my thing here. Yeah. You see the blue bit, that's the summary, and then here is all the separate ones individually. I just need to find 2020, I don't know why. Maybe they just didn't have, well, I guess they didn't have it because 2020 was COVID, maybe they just didn't make it. Yeah, it can go up and down, exactly, so just be aware of that. But here is my calculated average, 65 for paper 9. Obviously you'd have to get 65 on all 3 papers or more, like the average would be 65, and the total marks on all 3 would therefore add up to 196. An 8 is 55 out of 80, 7 is 44, a 6 is 34. It's kind of 10 marks different, I guess, every time. Yeah. You can see the percentages as well. But again, this does, yeah, you can screenshot this, but it does change, right? So just don't like hold me to this, okay? Sometimes it's higher, sometimes it's lower. Like if you have a look over here, these are the individual ones, right? June 2023 was 85% to get a 9, whereas you see June 2022 was only 81%. That's like 9 marks different. That's quite a lot of difference, isn't it? So just consider that. And then the one before that was 78%. I'm hoping it's not just getting harder. Oh no, that one was 83, that was 82, 84. Yeah, it just varies. Yeah, I can link this down below if you want the whole thing. You add to get bottom and sum, you just leave it. That's what I'm trying to kind of answer for you. So I don't know when you would just leave it. Like I don't know an example of the question where you would just leave it. It might be that in my case, answering whatever that type of question is, where you would just leave it, I might just do it a different way. So I might not even use fractions in that context, if that makes sense. So because in my head I'm like, I don't think I've made a fraction where I just did 1 over the other. I think I've always done 1 and then the 2 added together. So maybe that other type of question that you're referring to, maybe I just did a method that didn't use fractions, if that makes sense. So that's why I'm not really kind of clear on how to explain it to you. Some vector ratio, you just leave it. Ratio. Is it? I've always added it, so that's why I'm not so sure. I've always added it, even in the vector ratio ones. I've also always added. Yeah. Oh, you've got a 6 in your mock. No, I'm sure you can do it that way. It's just the way that I did it, I think, avoids that. So yeah, we'd have to find a specific question. If you found a specific question, like a past paper question, and then on my next live I can look at it, I can always have a look for you, so I can answer it in more detail. But I need like an example of the time where you would just put 1 over the other, and then I can have a look. You got a 6 in your mock in November. That's really good because that was ages ago now. So hopefully, I mean, I don't know what you want to get, but I'm assuming, yeah, that you'd be able to get 7, 8, 9, even more, I guess. Is it blurry? It doesn't look blurry when I'm looking at it. Maybe it's not loading very well. Oh, they want to get you to get a 9. Yeah. Okay. Yeah, you can see, I guess a 9, it looks on average to be, yeah, between 80 and 85%, doesn't it? Yeah, you're just trying to aim for all of it, really. I mean, it's not even 90% though, I guess that's a good thing. Yeah, it's fine-tuning the last things then, isn't it? To try not to lose marks so you do get above 80 or 85. I mean, if he got 5 in mocks, it seems like he's doing really well now, so joke's on you guys. He's obviously improved if that's true, but doesn't sound like it's even true, so yeah. doesn't really matter what you got in mocks, as long as you've improved by now, then that's great, isn't it? I would say based on how you've been answering the questions the last few days, I don't think you're on a grade 5 at all. I think you're much higher than that. For sure. Yeah, but he can't exactly lie about like his answers, really, so I don't even know what's going on right now. I don't think we need proof, to be honest. It doesn't really matter, does it? As long as like he knows what he's doing now, which it seems like he does from my point of view, so I think Akram's doing really well, to be honest. Anyway, so you got your grade boundaries there. I don't think there were any grade boundaries for 2020 because it was COVID, so maybe they just didn't publish them because I don't seem to, for some reason I don't have them here. I'm assuming that's why. So we don't have the official grade boundaries because obviously no one that year got grades based on the exams, but here's your average. So you can get a rough idea of what you might have achieved. But yeah, that's the end of the paper. Yeah, exactly. The 2020, it wasn't their actual, yeah, it was like mock results, or the teachers wrote something, didn't they? I don't know. It wasn't actually based on this exam, so that's why we don't have the official grade boundaries. But yeah, you can get an idea based on those averages that I sent, that I've shown you. Oh, you need the proof, right? Okay. I don't know why. Right. Okay. All right then, guys. I don't know why it matters whether he got a 5 or not, to be honest. I don't know how that's even relevant at this point. Do you think maybe have a look at the, I mean, we're working backwards in like backwards in chronological order. So at some point we're gonna get to the 2017 ones kind of very close to the exam, so that might work out quite well then. You can have a look at the 2017 ones, you know, closer to the exam. Because what is this? It's 2020, then we're going back to November 19, June 19, then 18, 18, 17. Yeah, there's 6 more. Yeah, I also feel like we shouldn't maybe just release where people actually live. That's probably not great on the internet, guys. Come on now. Oh yeah, and he's just put the location as well. Great. Yeah, I feel like you don't need to like let everyone know exactly where he's living. That's not so great, is it? Come on, guys. Okay, well, that's the end of the paper. Monday we'll be going through, I think, the June 2019, so we're keeping going backwards. June 2019, November 2019, then the 18s, then the 17s, and then it will be basically your exam. So we will have gone through all of the paper 1s that have pretty much been released. Obviously, if you want to go back and look at some of the recent ones like 2023, we've already done those, so go back onto my channel and have a look at the lives playlist. Those are already uploaded. Yeah, exactly. June 2019, paper 1 higher. We're just doing all the paper 1s right now because obviously your exam's in 2 weeks, and then after that exam, then we can switch back and go and have a look at the paper 2s and the paper 3s for the calculators that come afterwards. So we're just focusing on non-calculator for now. Yeah, so my Q&A kind of drop-in sessions. There's one on Sunday, 4:30 for about an hour, Sunday afternoon. I'm thinking to do them before my these ones, the papers. So these start at 7. I'm thinking maybe to do them at like 5 o'clock on the same days. So we'll see next week, but definitely Sunday, maybe Monday. And you can actually bring specific questions if you have them, and we can go through specific ones. Oh, does it have a really bad vectors one? Okay, well, yeah, we can have a look at that then. Yeah, that's probably a good one to look at then. Yeah, Reva, thank you so much for coming and participating. Good luck with your exam tomorrow. I hope it really goes well for you. It's tomorrow, isn't it, your exam? Hopefully that goes well for you. Yeah, find that other vector question with the fractions, and we can figure that out as well. And then I can maybe answer your question on that, because I'm not sure otherwise. Normally these ones, which are obviously the papers, normally I do them at 7 o'clock British summertime. So I don't know what that would translate to, but 7 o'clock British summertime. Now the Q&A ones where you can ask just random questions, yeah, 7 o'clock BST, not GMT, BST. Hang on, let me type it for you. 7 p.m. BST. It's Monday, Wednesday, and Thursday. Those ones, the papers. There you go. You can look up the change for your country. Oh yeah, hilarious, guys. So funny. The Q&A on Sunday will be at 4:30 p.m. Q&A Sunday 4:30 p.m. I might do one Monday at 5 o'clock. I'm just thinking about if that's what people want, to be honest. British summertime. Yeah, it's also, yeah, there's one called British. Yeah, it's the same thing, right? It's the same wording. Yeah, so UK is GMT when it's winter. But do you see how the clocks changed recently? I say recently, like a month ago. Now we're on BST because we're an hour earlier, like an hour ahead. So that's why I specified BST, because some countries do change the times. Sometimes some countries don't change. So obviously then the time difference is different depending on which time of the year we're in. So it's kind of confusing. Yeah, exactly. Yeah, daylight saving. So right now it's BST, and then after October it will go back to GMT. If that makes sense. Yeah, Reba, I'm saying 7 o'clock. 7 o'clock my country. What? Yeah. Trigonometric ratio. Yeah, you can ask about specific topics on the Q&A lives, which, as we said, will be Sunday at 4:30. Did I type that? Yes, I did. Let me pin it. Message. Oh, you can only pin one. Right. Yeah. Yeah, I think they mean, yeah, I was gonna say trigonometric ratio, I think they mean SOHCAHTOA. It's just a fancy way of saying it. Yeah, we can go through that. I also have a video on that if you want me to send you the video. Because instead of having to wait, and then if you have questions beyond that, you can ask in one of the Q&As. Hang on, let me grab it. There's obviously SOHCAHTOA for angles and for sides, so I'll send both. Yeah, thanks guys. Obviously I'm gonna just send this and then we can log off, but thanks for coming and interacting. Hopefully it was helpful for you. Let me just find this really quick, and then I can send it. Trigonometric, if I can spell it, that'd be great. Oh, that wasn't even the link, was it? Copy. There you go. Right, I'm trying to send the link. That's one of them. There are two. But if you click on that link, it'll be in the description anyway for the angles one. That's the one for the sides. There's also trigonometric ratios which come up in 3D shapes, which will also be linked in that video anyway, so you can find all of the ones that are relevant. So if you find that helpful, then have a look at that video first. Yes, the Q&A is at 4:30 p.m. on Sunday if you're from the UK, 4:30 UK time. Yeah, and then on Monday we'll go through I think the June one, June 2019, on Monday at 7. Wednesday we'll go through the November 2019. Thursday we'll go through the June 2018, and then the following week, do you see what I mean? We'll go through kind of each one. Yeah. Okay. All right, perfect. If there's no other questions, then we can leave it here then. All right, so I'll see some of you Sunday, some of you Monday. Right now the time is, in the UK, what is it, 9:30? Right now it's 9:30, so you can kind of track back if you want to from there. 9:30. Yeah, exactly. Yep. Okay, alright, thanks guys for coming. I'm going to finish it here and I'll see you Sunday or on Monday then.